Recently, astronomers have discovered a giant structure in space that has never been seen before. It has a ring shape and challenges all existing theories of the universe. The Big Ring, that's the name the megastructure got, is around 1.3 billion light-years across and has a circumference of 4 billion light-years. Such an enormous size makes it one of the largest cosmic structures ever observed by humans. Since the Big Ring is more than 9 billion light-years away from Earth, it's too faint to be seen directly. But if it was visible, it would take as much space as 15 full moons in the night sky. The structure itself is made up of galaxies and galaxy clusters. The Big Ring was discovered when scientists were analyzing data from the Sloan Digital Sky Survey, which is a catalog of distant quasars, objects so bright they can be spotted from billions of light-years away. They act like giant lamps which illuminate the galaxies their light passes through. If not for quasars and their light, we might have missed loads of galaxies, and they would have remained undetected. Anyway, back to the discovery. A student from the University of Central Lancashire spotted this ring-shaped structure that challenges our understanding of the universe. It's simply too large for its existence to make any sense. It's the second structure of such an enormous size identified by the same student. The first one was the giant arc, but we'll discuss it a bit later. What is important here is that neither of the structures is easy to explain based on our current understanding of the universe. Their distinctive shapes, ultra-large sizes, and even cosmological proximity definitely mean something. But no one can figure out what exactly yet. Researchers were using various statistical algorithms in attempts to identify potential large-scale structures when the Big Ring emerged. At first, the structure looked like an almost perfect ring in the sky. But later, additional analysis revealed that it had more of a coiled shape, like a corkscrew. The structure is also aligned face-on with Earth. Astronomers don't know what mechanisms could have formed the Big Ring. One theory claimed the culprit could have been an acoustic wave in the early universe. It could have given rise to spherical shells in the arrangement of galaxies today. Another idea suggests the existence of cosmic rings. Those are hypothetical defects in the fabric of the universe. They might have caused matter to gather along large-scale cosmic fault lines. Interestingly, astronomers used to theorize that the size limit of cosmic structures should be around 1.2 billion years. And still, both the Big Ring and the giant arc are much larger. The Big Ring's circumference is comparable to the giant arc's length, which is almost 3 times bigger than the estimations allow. Now, what is that mysterious giant arc? It's a truly enormous collection of galaxies, galactic clusters, and other space stuff, measuring 3.3 billion light-years across. It covers almost 7% of the known universe. But there's a problem. You see, at such a scale, there shouldn't be definable clusters throughout the universe. It goes against established models of the cosmos, making scientists' theories contradict real-world observations. The cosmological principle serves as the basis for scientific models of the behavior and structure of the universe. According to it, when you zoom out far enough, matter in the form of galaxies and galactic clusters should end up distributed evenly throughout space. And still, the recently discovered large-scale structures are so huge they don't seem to be compatible with the cosmological principle. It's also not clear whether any changes to this principle could help the situation start making sense. But some scientists suggest a possible explanation for this phenomenon. Perhaps gravity operates under different rules at gargantuan scales. But we don't know how exactly yet.
In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So, what is this mysterious blob? And how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for, hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light-years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now, technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole, and that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G-objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G-objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G-objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G-object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome.
These days, we discover exoplanets that are thousands of light years away. We descend to the ocean's depths and conquer the highest peaks. We study quantum physics and build quantum computers. But for some reason, we still don't know about these strange lights in the night sky. Some of them are still unexplained. Some may turn into unexpected discoveries, and others are large-scale falsifications. Let's start with the most mysterious burning balls. These lights regularly appear near the town of Marfa in West Texas. These basketball-sized lights suddenly appear out of nowhere in the middle of the night. They flicker, split into 2 parts, and take off into the sky several times a year. For several generations, people have seen blue, white, yellow, and other lights. The existence of these lights is not some legend, but a fact confirmed by scientists, but they still need to explain its nature. A local shepherd first noticed Marfa lights in 1883. At first, he thought that those were the fires that Apaches had made. Neighbors told the shepherd that they had seen the mysterious lights too. They all decided to check the Apache theory, and it turned out to be wrong. There were no traces of a fire in the place the lights had been flying above. Then, in the 40s, pilots of the nearest Midland airfield saw the Marfa lights. They also wanted to figure out the secret of this phenomenon, but didn't find out anything. More and more people saw the bizarre lights. Many of them were sure that the lights had been some ships of an extraterrestrial civilization. Others said those were the souls of wandering spirits. But scientific theories seemed much more realistic. A group of physics students conducted their own investigation and found out that the lights were the headlights of cars passing on the nearest highway. Okay, some lights do look like headlights, but what about those that take off into the sky and change their colors? It may be an optical illusion that occurs when a layer of cold air presses on a warm one. You can observe the same visual effect in the ocean, when it seems to you that a ship is floating in the air on the horizon. But if these lights are headlights and an optical illusion, why do people see them only a few times a year? Another version of the light's origin suggests that they're something like swamp lights. You can see mysterious bright balls rising into the sky in the middle of the night. Organic substances such as twigs, leaves, and fallen trees decompose in wet areas and emit phosphine and methane gases. When these substances come into contact with oxygen, they ignite, but there are no such wet places in West Texas. Where could this gas come from? There are a lot of oil and natural gas reserves in the bowels of this region, and all these substances can contain phosphine and methane. It sounds realistic, but scientists have not confirmed this version yet. Aerospace engineer James Bunnell explained the nature of Marfa lights by an unusual electric charge. Solid substances such as minerals and various crystals generate electricity under pressure, and this underground energy bursts out in the form of multicolored lights. But the scientist couldn't prove his theory. Marfa lights are still a mystery. Perhaps you can solve it. Other lights surprise people in Norway in the city of Hessdalen. Hessdalen lights, unlike other similar phenomena, can often appear in the night sky. And of course, people have recorded them on camera many times. From 1981 to 1984, Hessdalen lights appeared 10 to 20 times a week. Now, people observe them from 10 to 20 times a year. These giant balls float in the air, pulsate, flash, and move very fast. Also, the balls can hang in the air from a few seconds to several hours. Even though people recorded them on camera many times, scientists still cannot study them. Hessdalen lights are very bright, and if people understand their nature, they can create light sources using this unknown alternative energy. So far, there are several theories about these lights. Physicists suggest that the balls appear when clouds of dust containing scandium burn in the air. It's a light silver-colored metal. There are many deposits of this substance in the valley where people observe Hessdalen lights. Another theory says that the balls are the result of the accumulation of macroscopic crystals in the dust plasma. This plasma is formed when air is ionized and blah blah blah. In short, this is a complex scientific hypothesis that hasn't been confirmed. Scientists need a lot of funding to study Hessdalen lights. Researchers try to attract investors by saying that the mechanism of Hessdalen lights can encourage a technological leap in light-based technologies. Some of the most famous lights in the world appeared in Phoenix, Arizona in 1997. Tens of thousands of people saw two strange phenomena that day. The first was a giant flying triangle. At about 8 p.m., several lights appeared in the sky, lined up in a triangle. They flew in an even formation through Phoenix and disappeared far into the sky. The second phenomenon started about 2 hours later. People noticed lights hovering in the sky. They didn't form a triangle and moved freely. They burned with a bright light, flew in different directions, and disappeared behind a mountain range southwest of Phoenix. People were scared. They called the police and reported strange lights. Many were sure that those were ships of an extraterrestrial civilization. But the explanation soon appeared. Both incidents were the result of aircraft exercises. In the first case, people saw several planes lined up in a triangle. They flew over Phoenix and landed at an air base nearby. In the second case, exercises were held using lighting rockets. Several planes dropped glowing rockets, which were landing on tiny parachutes for a long time. They burned in the air and then disappeared behind a mountain range. Quite a logical explanation, but then, almost 10 years later, something strange happened again. On April 21, 2008, the Phoenix police station received hundreds of messages from worried residents who had seen strange lights in the sky. 4 bright balls hovered over the city, changing their shape. They became triangular, then rectangular, and then disappeared one by one. The police contacted the nearest airfield, but they said that the radar hadn't seen any objects in the sky. If those had been material things, the radar devices would have shown them. The police had no explanation. The air traffic controllers also didn't know what it was. The case caused a great stir in society. Many began to recall the phenomenon that occurred a decade ago and again claimed that those were extraterrestrial ships, but all disputes ended after 2 days. Some man called local television and admitted that he had created the lights using flares and helium balloons. He tied a flare to a balloon, set it on fire, and lifted it into the air. Then, minutes later, he repeated this action, then again, 4 times. Many witnesses of the lights didn't believe this story and continued to insist on the extraterrestrial nature of the mysterious balls, but they were wrong. Radars would have noticed something if objects with a metal surface had been flying there, but light balloons and flares were too small to be detected by radars. Secondly, all the lights were flying to the east. The wind was blowing in the same direction that day. Third, the time of the burning. Signal rockets burned for about 20 minutes. When one of those lights faded, the second burned down for another minute. And the last one went out about 20 to 30 minutes after the first fire was started. Witnesses mentioned the same duration of time. One of the locals was a neighbor of the guy who confessed to organizing the hoax. The neighbor saw him lighting flares around 8 p.m., at about the time when the calls to the police started. Phoenix lights have become a great example of how easy it is to deceive people and cause a stir.
China's Yutu-2 is a robotic mission to the dark side of the moon, launched on December 7, 2018. On January 3, 2019, it completes the first ever soft landing on the lunar far side. It lands in the von Karman crater, not far from the moon's south pole. Scientists are interested in this area. Cold, permanently shadowed craters at the poles contain water ice. These ice patches are uneven and are likely to be ancient. In the south, most of the water ice is concentrated in craters, and at the North Pole, it's spread more sparsely. In any case, this ice can be used once a long-term manned mission lands on the moon. Anyway, several days after Yutu-2 lands, it closes down its operating systems and hibernates through its first lunar night. It wakes up on January 29, 2019. All its tools operate normally. The rover travels 390 feet during its first full lunar day. One lunar day lasts for about 14 days, and a lunar night has the same duration. Moving and exploring during the day and switching off during the night becomes the rover's routine. It's the 8th lunar day when Yutu-2 stumbles across something incredible. This discovery makes the scientists put off all other plans for the mission. They focus on figuring out what the strange material found by the rover is. In the beginning, this lunar day is no different from any other. It begins on July 25th, when the rover starts making its way through an area pockmarked with tiny impact craters. Yutu-2 is helped and monitored by the driver team from the Beijing Aerospace Control Center. On July 28th, the team is preparing to shut the rover down for a midday nap. The sun is high in the sky. It means there are high levels of radiation and scorching temperatures that can damage the machine. Before powering Yutu-2 down, the scientists are looking through the pictures taken by the rover's main camera. That's when they spot it, a small crater filled with something that looks shockingly different from the surrounding landscape. Unable to identify the gel-like substance, the team orders the rover to check this bizarre finding. Yutu-2 cautiously nears the crater to examine the weirdly colored stuff. the machine uses special equipment that detects the light reflected off the substance. It's supposed to help the researchers to understand the structure of the material. Unfortunately, the nature of the unusually colored finding has remained a mystery for over a year. No wonder that both the finding and the fact that initially there were no images of the enigmatic stuff sparked curiosity all over the world. The only available description of the substance was that it looked like a randomly colored, shiny gel, something that's rather odd for the dusty, arid surface of the moon. But finally, the mystery seems to have been solved. The researchers have analyzed the information received from the rover's equipment. As expected, the substance turned out to be made up of rock, greenish and glistening breccia, in a sample no larger than 20 by 6 inches. It's kinda like a geologic version of Jell-O salad with fruit inside. If you melt it down, it'll look glassy. Breccia consists of sharp stones joined together by a chalky substance. The sample found on the far side of the moon is made up of a mix of different minerals. The main is a type of silicate that's one of the most common components in both the moon and Earth's crust. The piece also contains some glass, which means it could have formed during a volcanic eruption. But volcanic activity on the moon stopped more than 3 billion years ago. That's why the researchers are almost sure it's unlikely to be the source of the unusual finding. The material could have been created by a massive asteroid, comet, or meteorite that once hit the moon. During the collision, the pressure and temperature were so high that huge amounts of rock instantly melted. Some pieces cooled down rapidly enough to form glass. The rest gathered at the center of the impact crater and grew colder more slowly, forming a new rock. The substance was likely not formed in the Von Karman crater, but in the nearby Finsen and Alder craters. The hollow where the rover made its finding was just 7 feet across. Whatever left it had to be no wider than an inch. But then, it would be too small to create such a large piece of breccia. It's interesting that the material is similar to the samples collected by the astronauts from NASA's Apollo missions. One of those samples was made of dark, broken shards of minerals glued together. It also contains some black, shiny glass. It's not clear, though, whether it's the same as the stuff discovered by U-2-2. When the rover took photos and made its measurements, it was rather dark in the area. The quality of the images isn't that great. The experts also explain that the mission is examining a previously unexplored area of the moon. That's why they don't have any samples from that region to compare them with the greenish, shiny substance U-2-2 found. But if their guesses turn out to be true, then the far side of the moon might have more in common with the Earth-facing one than we used to think. But what's so special about this dark side of Earth's natural satellite, and why can't we see it? It's all because of the phenomenon known as tidal locking. Earth's only natural satellite rotates around its axis once in 27 days. It's the same amount of time it needs to go round our planet. That's why you always see the same face. To be precise, 59% of the moon's surface is visible to people. It means that you can catch glimpses of the satellite's far side at some times of the year. The moon's side we can't see is quite different from the one facing Earth. It doesn't have dark spots that are visible at night. Those are lunar basaltic plains called lunar maria. They were created by ancient volcanic eruptions. Those happened about 3 to 4 billion years ago. Instead of plains, the far surface of the moon has countless craters and tall mountains. One of the ideas about such a striking difference between the two sides is based on the collision theory. It claims that billions of years ago, Earth collided with another planet or some other massive space body. After that, the debris from this collision crashed with something that would later form our moon. That's why the satellite's landscapes differ so greatly. A more recent theory suggests that the Earth-facing part of the moon is warmer because of the heat radiated by our planet. During the period of volcanic eruptions, it was cooler on the farther side. That's why the minerals there became solid faster. They formed a protective layer shielding the moon's insides against the meteorites. but each impact left an impressive crater. At the same time, a much softer crust on the front-facing side of the moon spewed lava every time a meteorite hit it. After this lava cooled down, it covered the impact craters. Even though the far side is often called dark, both sides get almost the same amount of sunlight. The side we see looks a bit brighter because of the glow coming from Earth. There are two reasons why people are interested in exploring the far side of the moon. After leaving our planet, many radio waves get blocked by Earth's natural satellite. If astronomers could build their radio and optical telescopes on the dark side, they would get much more data. There would be no problems with any kind of interference. The telescopes would also be shielded from the glare of daylight coming from our planet. If telescopes were set up inside craters, they would also be protected from solar radiation. Astronomers would be able to get an incredibly clear view of the far regions of the universe. Plus, scientists believe there are great amounts of helium-3 on the opposite side of the moon. Earth is protected from solar winds that carry this gas by its magnetic field. But our natural satellite doesn't have such a shield. That's why experts believe the moon can be a perfect place for helium-3 mining. This rare element can be later used as the fuel for fusion reactors.
Let's cut the Earth in half. You can see all of its layers. Here's the inner core. It's about 40 times hotter than the inside of your oven. That's the mantle, an ocean of hot lava. Here comes the crust of the Earth, the solid surface on which our civilization lives. But if you look up, there are many layers besides the atmosphere and the ozone layer. Scientists recently discovered a strange bubble here, which protects our planet from radiation. And nope, it's not the Earth's magnetic field. This bubble is made of radio waves. Our planet grows like a Christmas tree in the radio spectrum. But we're interested in low-frequency waves, the ones that let us keep in touch with submarines. So, radio waves are like light waves, or regular ocean waves. Look at this one. The distance between the two peaks is the wavelength, and the number of these waves over a period of time is the frequency. For example, there are 10 waves in this interval of 1 second. So, can you guess the frequency of this wave? Yep, it's 10 Hertz. Cell phones use waves with a frequency of 300 to 3000 megahertz. So, add 6 more zeros to that number. But waves of that frequency don't penetrate barriers well. Think of how you lose your cell phone connection when you're driving through a tunnel. That's because there is metal inside. It's a conductive material that weakens the radio waves a lot. Salt water is also a kind of conductor. So, if the submarine is deep enough, the thick layer of water weakens the signal, and we lose communication. To maintain it, we send fewer waves but make them longer. In the same amount of time, the frequency of the short waves will be much higher than the frequency of the long waves. That's why they're called very low frequency waves. But, as it turns out, these waves travel all over the Earth and even into space. This is where things get interesting. The waves collide with particles of radiation from the sun. We think of the sun as a friendly giant giving us light and heat, but it actually emits a lot of harmful radiation. Each flare, or the electrical discharge of material on our home star, causes an even greater burst of radiation. These particles fly to our planet, just as radio waves do. They travel 93 million miles from the sun to Earth in 8 minutes and crash into our bubble, which acts as a shield. Basically, radiation particles from the sun accumulate in the radiation belts around the Earth. Our planet's magnetic field traps them, and a recently discovered bubble of very low-frequency waves lies right below this radiation belt. It helps us repel some of the harmful emissions. Analysis of old studies confirmed that the radiation belts used to be much lower and closer to Earth. But when our civilization began to use radio actively, our waves raised that belt higher. No one expected such an effect from simple radio waves, but it'll give us a way to protect astronauts in the future. When you're on Earth, its magnetic field keeps you safe from radiation. You can physically see it when charged solar wind particles make the air particles at the poles of our planet glow. This is an aurora. Next time you admire this beauty, know that it's actually the Earth saving you from some extremely harmful rays. But if you're outside the Earth's magnetic field, somewhere in space, I have bad news for you. Nothing protects you there. This is a big problem for astronauts who spend months on the International Space Station. Perhaps scientists will learn to create protective bubbles of very low frequency waves around space stations and spacecraft. The same is true for other planets. We're probably going to colonize Mars. There is no magnetic field there, and nothing can protect you from radiation. But if you create an artificial bubble there, you can reduce the harmful radiation. Another invisible bubble protecting us is the atmosphere. It's like a layer cake or an onion. Each level of the atmosphere has its own properties. The lowest layer that we live in is the troposphere. This layer contains 80% of the weight of all the air on the planet. It's also the main place where water vapor lives. And this is where the machine called weather works. The sun sends rays of energy to the Earth. Our planet's surface reflects them and heats the air in the troposphere. This makes it move and change places with the cold air, so all the wind, cyclones, storms, and tornadoes only happen in the troposphere, up to about 7.5 miles high. That's why commercial planes fly at an altitude of around 6 miles. The wind or other bad weather conditions hardly affect this area, and the air here is not as dense as it is down on Earth. Flying 1 mile above sea level is like moving through a biscuit. It's hard, but at a 6-mile altitude, flying feels like moving through light whipped cream. The plane almost feels no resistance, so it's a win-win. They save fuel and keep the passengers safe. A couple of significant downsides are that it's very cold and you can't breathe there. It's cold because there are very few air molecules to absorb heat from the ground and transfer it to each other. You wouldn't be able to breathe here for the same reason. That's why planes are equipped with oxygen masks, just in case. Let's go a little here. This is the stratosphere. There's even fewer air molecules up here, and that's where the weather probes fly. They're the kind of small balloons with computers people use to predict the weather. This part of the atmosphere also contains the well-known ozone layer. This is our shield against harmful ultraviolet radiation. Ozone is almost the same as oxygen, except it has 3 atoms in it. When harmful ultraviolet rays enter our atmosphere, they crash into the O3 molecule. The ray breaks the molecule into O2 and another oxygen atom. The ray itself is converted into heat, but the ozone regenerates quickly. A single oxygen atom joins the O2, and the ozone molecule is ready to protect us again. It's the invisible shield that protects us from radiation. It gave birth to all life on Earth. As our civilization developed, we started to emit freon gas into the atmosphere. We used to fill our old refrigerators with it. A single chlorine atom would detach from a freon molecule when in the air, and then it would bind a single oxygen atom. Now, the ozone can't regenerate like it used to. Fortunately, we banned the use of such harmful gases, and the ozone layer began to regenerate. Scientists expect it to fully recover in the middle of the 21st century. The stratosphere ends at about 31 miles. The next layer is the mesosphere, the coldest of them all. On average, it's about -140 degrees Fahrenheit. That's 5 times colder than your freezer. This is the layer of the atmosphere where incoming meteors start to ignite because of friction in the air. Then they will eventually burn up completely. The air here is too thin for airplanes or balloons to fly, but it's still too dense for satellites. So, this layer of the atmosphere is not well studied. The next layer extends from 55 miles above sea level to about 500. That's a little more than the distance between Las Vegas and San Francisco. Kármán line is situated in this layer of the atmosphere. This is the boundary between our planet and space. The thermosphere is where all our spacecraft and satellites fly. It's also home to the International Space Station. The temperature rises extremely. The air here is about 10 times hotter than your oven can produce. It's all due to solar activity. But you would never be able to feel this heat. The air molecules that carry the heat here are so small that you would literally float between them. Imagine a giant pool with only 3 drops of water. That's the thermosphere. And the highest layer of our atmosphere is the exosphere. This is the widest layer of our air bubble. Scientists believe its boundaries are about halfway to the moon at 120,000 miles. This is the point where the pressure of solar radiation begins to exceed the Earth's gravity. It's still part of our atmosphere. This means that astronauts who went on various space missions and have been on the ISS have actually never left the Earth's atmosphere.
Imagine stepping out of your spacecraft and setting foot on the surface of the moon. Under your feet, the ground is covered with a fine material that looks like powder. That's lunar dust. You look around and take a lungful of fresh air. It smells very different from the air on Earth, but still nice. Now, unfortunately, this is a highly unlikely scenario, and one of the reasons is that the moon has almost no atmosphere. Earth's natural satellite is too small, less than 2% of our planet's mass. That's why it doesn't have a magnetic field strong enough to keep an atmosphere. But even if the moon had it, solar winds would immediately pull it away. But if you could visit the moon 3 or 4 billion years ago, you'd see a very different picture. At that time, the moon most likely had an atmosphere. It formed at the times when powerful volcanic eruptions were rocking the satellite. Gases spread all over the moon's surface. It happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurling high into the air, falling to the ground, forming lava flows. That's how the basalt basins appeared on the surface of the moon. At one point, scientists on Earth got their hands on samples brought from the moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggested the moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days it's around 240,000 miles. That's why the moon looked much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. Neither was I. At the same time, the most recent studies have confirmed that our moon actually does have an atmosphere. It's composed mostly of hydrogen, neon, and argon, and contains some very unusual gases, like potassium and sodium. You can't find them in, let's say, the atmospheres of Mars, Venus, or Earth. Sadly, such an atmosphere isn't suitable for us oxygen-dependent creatures. But guess what? There's loads of oxygen on the moon. I know, it must sound confusing, but the thing is, this oxygen isn't in its most common gaseous form. It's trapped in a layer of rock and dust covering the surface of the moon. This layer is called the regolith, and it contains up to 45% oxygen. So, does it mean that if people learned how to extract this oxygen, we would be able to live on the moon? Not so fast. The oxygen in those rocks is very tightly bound into the minerals, and to break these components apart, we'd need tons of energy and special equipment. But if people managed to start this process, the moon would deliver quite a lot of oxygen. Now, there's a theory that the moon might have been formed during a collision between Earth and another planet. This planet must have been smaller, the size of Mars. It probably happened around 4.5 billion years ago. Another theory claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet, and that's how the moon appeared in the sky. And the least exciting theory claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. These days, the moon is the 5th largest natural satellite in our solar system. It's also one of the densest, second only to Jupiter's satellite Io. Most likely, the moon has a tiny core, no bigger than 2% of the satellite's mass. About 420 miles wide, it consists mostly of iron and sulfur. The moon's surface is dark, even though Earth's natural satellite is the brightest object in the night sky. But in reality, its reflectance is just a bit higher than that of asphalt. You might have heard that the moon, along with the sun, causes tides in the oceans and seas on Earth. The satellite's gravitational pull creates something called the tidal force. It makes the water bulge out on the sides that are the closest to the moon and farthest from the satellite. These bulges are what we know as high tides. But what not so many people know is that the moon also causes rocks to rise and fall, just like it does with water. Of course, this effect doesn't look as dramatic as ocean tides, but it's still noticeable. Earth's solid surface moves by an inch or so with each tide. Now, not only does the moon cause tides on our planet, but it also slows down its rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. You should really cut those. If one day it floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Since the moon doesn't have an atmosphere, nothing protects it from extreme temperatures. It gets incredibly cold on the night side, minus 390 degrees Fahrenheit. Meanwhile, the sunny side is literally boiling, with a temperature of 250 degrees Fahrenheit. Another thing the moon can't protect itself from without an atmosphere is meteorites. That's why the surface of the satellite is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. The moon is less seismically active than Earth. That's why these craters and other ancient formations stay in perfect condition for centuries. But even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. They start several miles beneath the surface. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say the moon has become around 150 feet skinnier than it used to be several 100 million years ago. So, how does it work? Well, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike a grape, the moon doesn't have any flexible skin. Its surface is hard and brittle. So, as the moon gets smaller, the crust cracks and breaks. Its sections get pushed over neighboring parts. Researchers are sure that such faults are still active and likely responsible for the quakes shaking the moon. Some of these quakes are pretty strong, up to 5 on the Richter scale. When you look up at the moon, you always see the same side of Earth's natural satellite. Like our planet, the moon rotates around its axis, but this rotation lasts around 27 days. This is the same time the moon needs to orbit Earth. Such a phenomenon is called tidal locking. Before space exploration started, people had never seen the other face of the moon. They didn't know what the far side looked like. While the near side of the moon is mostly large plains covering impact basins, the far side is rugged and cratered. The crust is thicker there, with less evidence of volcanic activity. Oh, by the way, the moon isn't perfectly round or spherical. It's shaped like an egg. When you're looking at it, one of its small ends is always pointing at you. Yep, right at you. This is the reason why the moon's center of mass isn't its geometrical center. In reality, it's a bit more than 1 mile off-center, like a poorly made golf ball.
During the recent years, scientists made 2 breakthrough discoveries about our universe. Thanks to new technologies, we've looked into the distant past. And we've learned something that can change our understanding of the universe forever. What are these discoveries and what do they mean to us? Let's find out. Recently, we unveiled the first color image from the James Webb Space Telescope. It's a mind-bending photo capturing thousands of ancient galaxies. This oldest documented light in the history of the universe dates back over 13 billion years. That's just 600 million years after the Big Bang. It's like getting a sneak peek into the universe's baby album. But that was just the beginning. Astronomers were expecting to see some tiny young galaxies. But what they found was a real surprise. Impossibly early, impossibly massive, and all that from just a tiny red dot. The lead author of the study, Ivo Labe, was working at the computer as usual, and suddenly he got two numbers. Age, 13 billion years. Weight, 100 billion stars. When he realized what that meant, he nearly spit out his coffee. But that red dot was just the beginning. The next day they found 5 more galaxies just like this. Turns out, these 6 massive galaxies are as old as the Milky Way itself. The entire research team was in disbelief. They were like, "Wait, what? These guys couldn't be that mature so early in time. Did we make a mistake?" But nope. The James Webb Space Telescope, the new cool guy on the space block, just has some serious skills. It can see through dust clouds with its infrared vision and spot galaxies that were previously invisible. Move over Hubble. There's a new stargazer in town. But why is it shaking things up so much? Because this discovery affects our understanding of how galaxies formed. Let's try to explain. A long time ago, 13.8 billion years ago to be precise, our universe was born. It was chilling out for a while, and then it started to form the first galaxies. And these galaxies were full of gas and dust. Eventually, this gas started turning into stars. Some galaxies were more massive and had more stars, and some were lighter and had almost no stars at all. In any case, they all grew gradually. The stars in them were born slowly and smoothly. That's how our current models explain this. But these new observations from the James Webb Space Telescope show an unexpected surprise. Looks like, even in the early universe, our ancient friends had lots of stars. More than what we would ever expect. If that's the case, then these galaxies are like the overachievers of the universe. They skipped the small and gradual growth phase and went straight to being giant universe breakers. According to our current cosmological model, they shouldn't even exist. But they do, so it looks like after the Big Bang, the stars were forming much faster than we thought, which is pretty weird. This could mean that there's something missing in our understanding of the galaxy formation. As you can see, these universe breakers are really living up to their name, causing a potential total consensus among scientists. The universe was like, "Hey, I'm about to flip cosmology models upside down." But let's not jump to conclusions. There are many theories that could explain these mind-boggling discoveries without breaking the standard model. For example, maybe the light we're seeing isn't coming from stars at all, but from the swirling disks of doom around supermassive black holes. These colossal cosmic beasts can gobble up matter and spit out a dazzling light show. And James Webb Telescope's keen eye is picking up on these enigmatic accretion disks like never before. Or maybe these galaxies could be playing hide and seek with us. Maybe there's more to the story that we haven't seen yet. After all, the universe is vast and mysterious, and we've only just begun to scratch the surface. And whoa, we really need to slow down here. Before we even try to explain all this stuff, we need to confirm whether these ancient galaxies really are that old. Although even if they're actually just supermassive black holes, it still shows an astounding change. We'll have to wait about a year to find out. One thing's for sure, the James Webb Space Telescope has definitely taught us a valuable lesson. Expect the unexpected. And this is just the beginning of unexpected. Ivo Labe's team wasn't the only one who made such a huge breakthrough. There's also a team that claims that they've unlocked the secrets of the universe's past, and that's worth 2 Nobel Prizes. Move over James Webb Space Telescope, because this discovery came from an antenna that's smaller than a fridge and costs less than $5 million. Talk about space bargain hunting! The astronomers caught this signal that showed some surprises. It was coming from the earliest stars of our universe, back in the days when they were just beginning to twinkle. Say hi to our celestial ancestors again. Now, the signal was pretty weird. The temperatures were unusually low, and there was a pronounced wave that left astronomers scratching their heads. What could be causing all this? Well, there's a theory. Dark matter may have been at work, and if that's the case, then we can really be on the verge of a great discovery. Imagine you're looking at the night sky filled with stars, but there's something else there that you can't see. It's like an invisible cloak that covers the entire universe. Scientists call this mysterious stuff dark matter. Dark matter is like the ghost of our world. It doesn't emit, absorb, or reflect any light. We can't see it with telescopes or our eyes. That's why we call it dark matter. But if we can't detect it in any way, how do we know it exists? Because of its gravitational pull. One day we noticed that our understanding of how galaxies were created was incorrect. According to our calculations, they should have been some chaotic gas, but something held them together, turning them into spirals, like some kind of invisible glue. Then we thought, maybe this invisible glue really exists. If the moon was invisible, we would still suspect that it exists somewhere because its gravity affects the tides on Earth. This is also the case with dark matter. Its gravity influences the motion of galaxies and other cosmic objects. In fact, dark matter makes up a huge chunk of the universe, about 27% of it. Moreover, the normal matter we can see, like stars, planets, and galaxies, only make up about 5% of the universe. So even though we can't see dark matter, there's actually more of it in the universe than everything we can see. Scientists are still trying to figure out if dark matter exists and what it can be made of. Some theories suggest that it could be made up of exotic particles that are different from the particles that we're used to. Others think that it might be some kind of weird, undiscovered form of matter that doesn't interact with light at all. Anyway, it's an intriguing mystery, and if we ever confirm the existence of dark matter, our understanding of our world will change forever. So now you can understand why the excitement in the scientific community is palpable. If this discovery is confirmed, then we will get the first real proof of dark matter. This discovery may be even more important than the Big Bang itself because, as astronomers put it, we are made of star stuff, and so we are glimpsing at our origin. But of course, we still have to wait and explore all this in great detail. In science, one should never rush to conclusions. And while scientists study this stuff, we'll be here, on the edge of our seats waiting for the next space blockbuster to unfold. The universe never ceases to amaze us with its wonders. Who knew that such a small and humble antenna could unlock such cosmic secrets? It just goes to show that in the vastness of space, even the tiniest discoveries can have the biggest impact. Keep looking up, and who knows what other cosmic surprises are waiting to be uncovered.
Enceladus. Saturn's ocean-covered moon spews water into space non-stop. The liquid leaves the insides of the moon through fractures in its icy crust. In the mid-2000s, the Cassini spacecraft analyzed the composition of these jets and spotted molecules that included ammonia and carbon dioxide. Both compounds are crucial for the existence of life on Earth. But recently, scientists have made another analysis of the Cassini samples. And this study has revealed a great chemical diversity of Enceladus. It makes this small icy moon one of the top candidates for finding life in the solar system. In an attempt to find out the true chemical makeup of the moon, researchers at NASA examined the data collected in 2001 and 2012 again. All this information was gathered by NASA's Cassini-Huygens mission. It flew a spacecraft through the impressive water plumes of Saturn's moon many times. The samples were analyzed by a special instrument identifying compounds by their molecular weight. This instrument is called a mass spectrometer, and Cassini had one on board. The initial analysis showed that the jets contained 5 types of molecules: water, carbon dioxide, ammonia, methane, and molecular hydrogen. But later, experts spotted a few bigger and heavier compounds, including ethane and hydrogen cyanide, as well as traces of methanol. The initial Cassini analysis didn't show these compounds because the equipment on board the spacecraft wasn't capable of identifying them. That's why it came as a surprise that Saturn's small moons could be so chemically active and able to produce heavy molecules. Together with previously found components like water and ammonia, the newly discovered molecules might serve as fuel and building blocks for microbes, which in turn means that they could probably support an independent origin of life. It's one of the reasons why, after the discovery of its oceans, Enceladus has been one of the main targets in the search for extraterrestrial life. The molecules might be mixing together through the hydrothermal activity on the moon's seafloor, creating a habitable environment where life could appear. So far, scientists haven't found any evidence that could indicate that such a process has actually been going on. Plus, no one knows yet how the erupting water makes its way through the icy shell of the moon. Still, The most recent findings might help ongoing and planned missions exploring other ocean worlds similar to Enceladus. One of such worlds is Jupiter's watery moon Europa. This place is likely to have the same properties as Saturn's moon. Hopefully, we'll get the answers to these questions soon, with the help of the European Space Agency's Jupiter Icy Moons Explorer spacecraft. At the moment, it's on its way to the Jupiter system. But then another question might arise. If we found the conditions where life can originate and even thrive, can't this fact already be proof of the existence of extraterrestrial life? Doesn't it mean that life must be abundant in the universe? Then why haven't we come across other species yet? The answers to this paradox vary from optimistic to downright terrifying. It might be because we haven't been looking long enough, or maybe we haven't been emitting enough traceable signatures for other civilizations to find us. Or perhaps no species have ever made it to the point where they could come into contact with other civilizations. There's also the frightening dark forest hypothesis. It's a theory claiming that loads of alien civilizations exist throughout the universe, but they are all silent and hostile. They try to maintain their undetectability for fear of getting destroyed by another unfriendly species. So, following this hypothesis, we can presume that any spacefaring civilization must view other intelligent forms of life as an inevitable threat, and the best course of action is to hide its existence altogether. This makes the cosmic electromagnetic spectrum eerily quiet, with no evidence of any intelligent extraterrestrial life. This way, the universe can be compared to a dark forest filled with armed hunters wandering among trees like ghosts.